Bismillah ar-Rahman ar-Rahim. This is Dr. Ahmad Al Faris. We are going to start talking about work, energy, power, and efficiency today. First of all, what's the meaning of energy? It's not included in the syllabus. That's why we put a cross. If we put a tick, that means it's included the definition in the syllabus. But what's the meaning of energy? What do we mean by the word energy? How can we use the word energy to describe things in physics? Energy, if you want to send me the answers, energy is the ability to do what? The ability to do exactly, to do work. If you have energy, you can do work. If you don't have energy, it's very hard to do work. Okay, that's the simplest form of what, or definition of energy. If we have energy, we can do work. If I don't have energy, I can't do work. For example, if I have 50,000 US dollar, 50,000 US dollar, and I want to buy a car that's cost $30,000. Can I buy this car? Yes, I can buy this car because I have the energy, the money to do this work, to buy this car. But if I don't have the 30,000 GDs, I can't buy this car. Okay? So how much left when I buy this car? It's left how much? 20,000 GD. So actually the difference of the energy, the change of the energy, the change of the energy is equal to the work done. So 50,000 minus 30,000, it's 20,000. So 50 minus 20 is the work done, which is 30,000. And both of these work and energy, both of them, they have the same unit. What's that unit of energy? Who can tell me what's the unit of energy? The unit of energy is exactly, thank you, Muhammad, is joules, letter J. Yes. Okay. Now, first of all, we have to know that from last time that we have several energy resource. Okay, so the sources of energy are, they can be renewable, and what? Non-renewable. Renewable and what? Non-renewables. These are the what? Energy resource. Okay, so who can give me examples now? So you can send me, okay, on the chat for the renewable energy source. Like what we have renewable energy source? We have a lot. Send me if you please. Yes, thank you. Solar energy. Okay, tidal, exactly. Okay, wind, bravo. Okay, hydroelectric. Okay, water waves, exactly, bravo. Okay, and what? Geothermal, exactly. Fossil fuel is not renewable. Geothermal, okay, and there are many. So what do I mean by renewable energy source? That these forms of energy, they will never run out. They will never run out during human life. Okay, they are never run out during human life. But on the other hand, if I'm talking about what non-renewable energy resource, okay, what we are going to talk about, what are the non-renewable? Who can give me examples? Okay, there are fossil fuels, yes, exactly, and we have several types of fossil fuels, okay, like oil, petrol, coal, okay, tamam, gas, okay, natural gas, and we have also what? Nuclear, what? Energy. Nuclear, what? Energy. All these are what? Energy resources that eventually they will run out during human life. Eventually they will what? Run out. Eventually run out. So this is the main difference between energy resource and for renewable energy resource and non-renewable energy resource. And the advantages of renewable energy source that they are exist, okay, and they are free and they have low cost for long term, okay. But the disadvantage, they are not efficient. They cost a lot in the beginning, most of them, okay. That's what we'll talk about that last time, okay. The non-renewable energy resource, the advantage of them, okay, they are efficient, okay, and easy to be transferred. The disadvantage that they causes pollution, okay, that's the and maybe acid rain or nuclear waste, okay. These are, yes, okay, these are the main advantages and disadvantages about energy resource for renewable and non-renewable energy resource and on Earth here, as far as human use so far, okay. So yeah, it's written. It's written in front of you. I make share screen. You can see the screen, right? Okay. Okay. So again, renewable energy resource, they are like solar, tidal, wind, hydroelectric, water waves, geothermal, okay, biomass, okay, or biogas, okay. All these are renewable. Why they are renewable? Because they eventually never run out during human life. They will never run out during human life. They stay every day whenever there is sun. Okay, the main source of energy on Earth, most important is what? The renewable energy source, okay, is the sun, except the geothermal, okay. But as we can say, the non-renewable, okay, they are limited, okay. We have fossil fuel and nuclear energy, and eventually they will run out during human life, maybe after 20, 30, 100 years. All of these energy, non-renewable energy source, they will eventually run out, okay. We have to know, it's very important. It's very important to know something called efficiency. What do I mean by that? So we are going to talk about that in details. Now, when I buy the car by the $30,000, not all of this 30,000 is the cost of the car. Not all of the 30,000 is the cost of the car. Hold on. نشوف والله في ناس بيحكوا لي مش قادرين ندخل، مع انه انا في ability انا ما عملتش بلوك لاي حدا، الكل بيقدر يدخل. تمام. اي حدا حاب يجرب يدخل مره ثانيه يبعث مسج وان شاء الله خير. اوكي. الرجاء الكل ايش يدخل عنا. لسه الزوم بوسع فوق ال 100 شخص. اوكي، احنا لحد هلا وصلنا تقريبا 40. اوكي. So not the whole 30,000 GD, it's the cost of the car. Maybe the cost of the car is about 20,000 GD, and 10,000 GD are taxes, okay? So I'm not going to give the whole money that I give that, for example, like this example for electric lamp, they use 100 joule of electric energy. This is called Venn diagram. Maybe 75 joules, okay, 75%, 75 joules of the energy, I use it as light because this is neon lamp or LED lamp, which are efficient compared to the filament lamp. And the 25 joules, 25% is wasted. So that means not all the energy are useful in in our life. Okay, a lot of the energy is wasted as heat, as sound, or other unwanted energy resources. So we have wanted energy resources, okay, and unwanted, okay, wanted energy form, sorry, and unwanted energy form in any mechanism or machine. Now we are going to talk about that in what? In details. There's a formula. I'm going to tell you the formula later on. Before we talk about the formula, always they say that we have something called conservation law of energy. Conservation law of energy. Who can tell me what's the meaning of conservation law of energy? Conservation law of energy, yes? Tell me what, you can send me. Yes, send it to me if you please. How to conserve energy. What that means, how to conserve energy. Conservation law of energy means what? Yes. It means, yes, exactly. Energy cannot be created nor destroyed. Okay. It's only transfer from what? Exactly. It's only transfer from form to another or from object to another. Thank you. So from this, we can return back here. Okay. And we can see that for this electric lamp that, okay, use electric energy as 100 joule. Okay. Now this energy, we didn't destroy it. We transfer to other forms of energy, to light and heat. So now we are going to give a lot of examples about how the energy is transferred. Some of them, they are useful, or some of them, they are unuseful. So this is the total input. And this is the useful energy. I need the lamp to make light, useful in output. And this is what the wasted or unuseful, okay, wasted what output, okay. So actually, it doesn't mean wasted that I destroy it or it's not useful. I don't want it. I don't want the light to produce heat. I want it to what to produce what light. Yes, some electric lamp they has problems to produce sound. Thank you, Muhammad. Okay, so energy cannot be created, neither destroy. Okay, so it's only convert from one form to another or from one object to another. So for example, I have money, 50,000 GDs, and this money, okay, when I buy the car, I transfer it, okay, from being money, cash, to be what a valid for a car, okay. And this car, maybe it becomes more expensive in the future, or it will be less price in the future. So it depends, okay, how much efficient we are going to talk about it, okay. So let's talk about examples here, okay. There are many forms of energy. Well, we once talk about energy resource. Now we are going to talk about energy what forms here, okay. But we have to know that energy transfer from one form to another in many examples. For example, electric lamp. What is the input and what is the output? And don't forget, the output, it's divided into useful and wasted, unuseful, okay? So what is the input? And I will repeat it. Yes, I will repeat it. What is the electric lamp? What is the forms of energy that it's input, okay? And what is the output? Yes, the input for electric lamp, yes, thank you. It's electricity, electrical. And the output, it can be what? Light plus what? Plus heat. This is the main source. Maybe you can find sound or other source. Yes, shukran, shukran. Yes, bravo. Another example here, we have the radio. And in radio, you put electrical energy inside it. This is the input. And the output is what? Sound. It produces sound. Plus what? Plus also heat. So that's one of the reasons why we have global warming here, because a lot of the appliances they transfer energy as wasted into heat energy, so the temperature of the global increases. Okay, this is the radio. So electrical into sound plus heat. A third example, we have microphone. What's the input of the microphone? If I have a microphone, the input is my voice to it, like now when I'm talking to the speakers here. So the input is sound, okay, and it becomes into the wires, okay, as electrical energy. Now, eventually, this electrical energy is stored inside the computer, it's stored in CD, okay, go to a loudspeaker to your AirPods and becomes louder. That's something else. I'm talking about the process of the microphone from sound to what? To electrical, okay, plus what? Plus heat, okay? Yes. Okay, good. Thank you for your the answers that you sent. Now, falling objects. Any object that falls, it has an energy in the top. Okay, and this energy we are going to use it during falling. So we're going to talk about that in details. Yes. So the falling energy, object energy, it was gravitational potential energy, GPE, gravitational potential energy. You can write it GPE, okay, unless they ask about you to explain. Also, you can write GPE or you can write gravitational potential energy. And during falling, this energy is transferred into what? Into kinetic what? Energy. Into what? Kinetic energy. Plus, maybe there's some heat due to what? Air resistance. AR means air resistance, okay? Now, if we are dropping it from vacuum, there is no air, so of course there is no what? Air resistance, okay? So falling object, in the top, it has gravitational potential energy. We are going to talk about that in details. And as it falls, this energy is transferred to other forms to what? To kinetic energy. Yes, we can't talk about the headphones that they get out what? Sound. So the energy was electric and becomes sound. We have a lot of examples. Now we're going to discuss it, okay? Next, now, if this falling object hits the ground, as it hit the ground, we are not talking about bouncing, as it hits the ground, all this kinetic energy is transferred to be what? To be exactly, to be sound plus what? Plus heat. Exactly, bravo. So, no, it will not return back to a gravitational potential unless we give it another height, unless it bounces up. Yes, so it falls down, it has gravitational potential energy. During falling, it becomes kinetic energy. During hitting, we don't know what's happening. After hitting, maybe it bounces, maybe it does not bounce. It becomes sound plus heat, and maybe strain energy stored inside the object. If we are talking about rubber band or something that elastic that can change its shape. So maybe, yes, thank you. Maybe you are going to talk about strain energy, okay, if they are talking about change in the shape. Yes, okay, all these are suggested examples for object that hits an edge of the ground. Okay, next here, for any also, okay, maybe it stick to the ground, we don't know. Maybe also falling object, okay, and this falling object hit the water surface. What will happen to this energy? The gravitational potential energy becomes kinetic energy, and eventually, as it hit the water surface, it becomes water waves or water splashes, okay, water waves, plus sound, exactly, okay, plus what? Plus this object, as it hit the water surface, it didn't stop. It still has kinetic energy to sink. So kinetic energy to what? To sink. Maybe it floats after hitting and goes inside. Maybe it keeps sinking. We don't know. We are talking about during hitting water surface. Okay. In the springs, we have a strain energy. Yes. Strain energy is this energy stored inside the spring or inside any object that change its shape. So it can return back to its original shape. That's the meaning of strain energy or elastic potential energy. Any object that it's elastic, when it, for example, this is a ball, it hits the water surface, or sorry, it hit the ground, okay? It changed its shape a little bit, squeeze or scratch, then what? Okay, as it compressed, then it released back and returned back to original shape, then maybe bounce. So during hitting, the energy stored in it to become what? Compressed. So that's called what? Strain energy, okay? Yes, maybe it returned back to its original shape, maybe not, we don't know. It depends on the object. So that's why I said object, okay? So it depends on the question that they give it to us, okay? Yes, okay. Next, throwing an object vertically upwards until it reached the maximum height, okay? We don't know if it sink or float. In the instant that it hit the water surface, okay, it still has kinetic energy to sink. Now, we don't know how much the water resistant it is and the density of the object. We don't know enough. I'm talking about generally objects. I'm talking about the general information, okay? General examples. Now, yes, you are welcome. So, throwing an object vertically upwards. When you throw an object, what was the energy inside your body that you use it to throw an object upwards? What is the name of the energy that you use inside it? No, when you throw it, it's kinetic. But before that, no. Inside your body, you are eating food because you need this energy. Exactly. Thank you, Noor. Exactly. It's called what يا شباب? في ناس بلشوا يكتبوا صح. Thank you, Yusuf. Thank you, Leith. يا سلام. يا سلام. Molecular energy. There's nothing called molecular energy. Yes, Muhammad. Yes, Abdul Rahman. It's called chemical energy. So chemical energy inside the body, we throw it to be kinetic energy plus heat, and this heat inside the body, you become warmer, okay? And as it falls up to reach the maximum height, it has what? Gravitational potential energy, GPE, gravitational potential energy, okay? Plus also heat due to what? Air resistance, if there is what? Air resistance or other friction forces, okay? So again, the energy initially inside your body, when you throw, it was chemical energy. You throw it, it becomes kinetic energy. You throw the object. We don't know what's the characteristic of this object, what is the description of it, and there's some energy, heat, called inside your body. That's why you are warmer. على فكرة شباب, approximately 15% of your energy you are using it, and the rest is wasted inside your body. You are heating your body. Okay. Selma, what's your question again? What do you need to ask? Which example? Which one? Why chemical? Yes, when you eat food, okay, there is chemical reaction happens when you burn this food, okay, to use it in your muscles, like petrol, okay, gasoline. When they use it inside an engine for the car, they burn it, and it produces what? Heat energy. Then this heat energy becomes kinetic or whatever. Okay, inside our body, only we use approximately 15% of our energy, okay, chemical energy, to burn it, to move, to jump, and the rest, 85% as heat. Okay, it's wasted energy. Okay. Thank you, Abdulrahman. Because of the causes hydraulic acid of the stomach and other substances. Yes, that's why they call it chemical. Is it okay, Salma, now? Is it understood? Okay, inshallah. You are welcome. Okay. Next here, we are going to talk about another example. Okay. Someone was walking up the stairs, then stops. So what was the energy inside your body to go up the stairs, okay, and eventually stop? What is the energy inside your body again? It is chemical. Yes, Marwan, thank you. It's chemical. So this chemical energy, okay, we're going to use it again, chemical energy, to become what? Kinetic energy. And don't forget, not all the kinetic energy is useful inside the body to go upstairs. You need to move your arms to be balanced while you are going upwards. So this is also wasted energy called chemical energy in the arms. Okay, it's not useful, it's wasted. Then this kinetic energy, eventually when you reach the maximum height at the top of the stairs and stop, it becomes what? Gravitational potential energy, plus what? There is, of course, wasted energy. Yes, bravo, Abdurrahman, there is heat. Why there is heat? Because your body, what? Your body used some of maybe 80% of the chemical energy inside your body to warm up your body. Okay, so walking by the legs, that's why I put kinetic energy, and balancing by the arms, that another kinetic energy, is not useful. Yes, there's sound. Sometimes there's sound of the steps, but not necessarily always there's sound. Okay, tamam. Okay, that depends on how athlete you are. For example, one of the most athletic person on the earth here, he has an efficiency approximately 17 or 18%, Cristiano Ronaldo. And most of the athletic and gymnastic people, okay, they are what? They are efficient, their body. Okay, they don't use a lot of wasted energy, okay, in their body. That's why, okay, they are athletic. Exactly. Why when it stops, it becomes kinetic energy? Because he or she goes upstairs and reach a certain position in the top. We are going to explain why it becomes gravitational potential energy, because it has a higher position. So it was in the ground state, for example, on ground floor, and goes upstairs to the first or the second floor. That means the position becomes higher. When the position is higher, we are storing what? Gravitational potential energy inside the body. Did I answer your question, Marwan? Did I answer your question? Yes, you are welcome. Okay. Next example. Look here, we are going to be more details with more examples. Solar energy is heating the surface of an object. Now, what is the energy? You are welcome. What is the energy inside the sun? Now, we said that the energy inside our body is chemical. Is the energy inside the sun is chemical because the sun is burning here? Thank you, Yusuf. It's thank you, Layla. Thank you, Salma. They call it what? They call it nuclear. It's not thermal energy. The sun is not burning. It's called nuclear energy. What form of energy we are talking about? Is it nuclear fission, or sorry? Is it nuclear fusion or nuclear fission? Is it like the nuclear reactor, the nuclear bomb, or it's like other stars? There's hydrogen and hydrogen combined to form helium. Yes, exactly. It's a nuclear fusion. So nuclear fusion برافو عليكم. برافو. تمام. رائع. So we have to mention that it's a nuclear fusion, and this nuclear fusion produces heat plus light, and this light, the radiation, okay, becomes heat, heat radiation, okay, becomes heat to raise the temperature, to raise what? The temperature of the of the object, okay, of the surface of the object, to raise the temperature. What is the most important form of energy or waves that maybe you studied, maybe not, that we are going to use it to what? To increase what? The temperature. What is the form of electromagnetic spectrum that we have to use it to heat any object? We call it IR. Do you remember what's IR? We didn't talk about it yet. We are going to explain when we talk about thermal physics. What's IR? IR is exactly, shukran, infrared, exactly, infrared radiation. So what's the difference between heat inside the solar energy, and light? It's the electromagnetic spectrum, the waves that come and reach us. So when I talk about heat radiation, because I'm talking about heating here, okay, that I'm talking about mainly the infrared, which we call heating radiation, that we are going to talk about it in details when we talk about what? Thermal physics later on. So all these examples, thank you, Muhammad, all these examples are examples for how the energy is transferred from one form to what? To another. Okay, good. Okay, next, what do we have here? What about the difference between nuclear fusion and nuclear fission? We didn't explain that. We are going to study it in nuclear physics, the last topic of your syllabus. But nuclear fusion, it's two small nuclei, they merge together, their nucleus, and becomes one nuclei, which is called helium. That releases a huge amount of energy. That happens in the stars. But nuclear fission is bringing a heavy nucleus like uranium, plutonium, and make a chain reaction, nuclear reaction for it to split, okay, and divide and break to what is two small nuclei, okay, for example, kryptonite and beryllium, or whatever the elements it is. So that's the difference between nuclear fusion and nuclear what? Fission, okay? Yes, both of them, they produce what? Yes, both of them, they produce energy. So yes, now nuclear power plant, a lot of countries, they use now nuclear power plant to produce electricity in their countries. So what they actually do, they use uranium in something called nuclear fission with double S, okay? Nuclear fission in something called uranium or plutonium. And this, as it happens, it produces what? Heat energy. And this heat energy, we use it to become kinetic energy, boiling water, I'm sorry. Okay, so again, ya shabab, we use this nuclear energy, okay, from nuclear fission in uranium, it's split to become heat, and this heat, we use it to boil water, and as the water is boiled, okay, it becomes, hold on, في ناس عم بيبعتوا لي invitation مش عم بيقدروا يدخلوا، خليني أجرب. Okay, الأمور تمام. And this boiling water becomes steam, having okay, and as it becomes steam, it becomes having a kinetic energy. Exactly, kinetic energy. It doesn't matter what type of uranium. Later, we are going to study that later. And thorium. Yes, shukran. Okay, kinetic energy in steam, and this steam pass through pipes. Okay, and this steam pass through pipes with a very high kinetic energy to still kinetic energy to rotate turbines, rotating turbines, that what we explained last time, okay? And this rotating turbines, they are connected to generators, and the generators, they produce what? What they produce? Okay, they produces what? Electricity, yes, electricity or electrical energy. Electrical what? Energy by something called what? Generator. It's very important for us as a human being the electricity now. Okay, we can't live without electricity. It's very difficult. We return back to cave time. Okay. Now, so a nuclear power plant, the nuclear fission, okay, for uranium, plutonium, thorium, it doesn't matter. They produce heat, and this heat we use it to boil water, as we are going to explain it later on. Details we explained before, and we are going to explain it to maybe next class or at the end of this class. And this boiling water becomes steam, okay? And this steam passes through pipes, okay, with kinetic energy. And through these pipes, we have turbines that we rotated. We still have talking about kinetic energy. And eventually, okay, we use these rotating turbines to rotate generators to produce what? Electrical energy. Now, all these process it's not 100% efficient. A lot of energy is wasted, okay? Tamam, a lot, infrared, IR is infrared, okay? We are going to explain when we talk about thermal physics, okay? Yeah, okay, tamam. Hydroelectric power station is one of the most important and easy ways to generate electricity, like السد العالي في مصر, the Nile River, okay? The high dam, okay, السد العالي. Hydroelectric, what they do? There is a gravitational potential energy stored where? In the water behind dams. And whenever we have more water with higher water, okay, we have more gravitational potential energy. So whenever the dam is higher, yes, shukran ya Lujay, okay, this gravitational potential energy, okay, inside the water, it becomes what? It becomes kinetic energy by flowing water through pipes, okay, flowing water. And this flowing water, okay, it's what? It becomes also kinetic energy in rotating turbines, okay. And these rotating turbines, eventually it becomes electrical energy as the generators are what? Rotated, okay? Generators. Yes, yes, bravo, yeah. Okay, so I don't have the paper now. Can you please? I can't send it now. I have a class. I will send it later. Okay. Shukran لك. Okay. If you have anything, you can send it back to me on directly on the WhatsApp. Okay. You are welcome. طيب. These are few examples. There's many examples about how energy transfer from form to another. They can ask about any one of them. Okay. So the main two forms of energy that they ask about it by formula and by calculations, they are the kinetic energy and what? The gravitational potential energy. So what's the kinetic energy? Any object that has on motion, on movement, okay, it has what? Kinetic energy. So it's the energy of movement because it has what? Speed. So since the object has a speed, of course, it has what? Kinetic energy. But potential energy, it's the energy of what? Of position. So any object that has a height, okay, relative to a standard, for example, the ground, the first floor, the top of the ground, it doesn't matter where the location, the height from a certain point, this height, we call it what? Okay, we have it as gravitational potential what? Energy. So what is the formula for the kinetic energy? Yes, both of these energy, they are stored inside this energy depending on their position or their speed, okay? Yes, shukran ya Aya. So the kinetic energy, they use letter Ke to represent it, or capital E with a small k inside, okay? It's equal what? Yes, bravo ya Yusuf. It's half mv squared. This is the formula. Half mv squared. What actually is the kinetic energy? Again, the kinetic energy, it is in joules, and m, it's the mass, and it's supposed to be in what? In kilograms, and v is the speed, and it's supposed to be in what? In meters per what? Per second. Okay, so usually students, they forget to write the formula kinetic energy equal half mv squared. So when they forget to put the V, they get the wrong answer. So you have to write the formula in the question, okay? So kinetic energy equal half mv squared. Potential energy, gravitational potential energy, has another formula. Okay, what's the formula for gravitational potential energy? Exactly, gravitational potential energy is equal to what? mgh. Wait, Aya and Lath. These formulas, we cannot use them, okay, in this situation. Don't memorize them. It's not like this, okay? Thank you for sending the formula. This is a huge mistake that student, they say that half mv squared equal mgh. No, it's not necessary. It's not always. I'm going to prove that in less than 10 minutes. Okay, so gravitational potential energy, which is equal mgh. Okay, and we know that the unit of energy, it's supposed to be in what? In joules. Okay, and m is the mass. It's supposed to be in kilograms. And g is the gravity acceleration, and here on Earth it's 10 meters per second square, unless they tell us another position. And h is what? Is the height. Okay, yes, gravitational potential energy, PE, or gravitation. We have two forms of PE: elastic potential energy and gravitational potential energy. The formula of gravitational potential energy is mgh, and h is the height, and it's supposed to be in meters. Again, we have two forms of energy that they ask about it in calculations. Okay, the kinetic energy, the energy of motion, the energy of speed. Okay, any object that has a speed has kinetic energy, and the kinetic energy, as you can see, it's equal to half multiplied by the mass multiplied by the speed square. And the mass is supposed to be in kilograms. You have to convert it, and the speed is supposed to be in what? Meters per second. So you can write the energy in what? In joules. Okay. I didn't say that you wrote that Saya and Lath and other people there, you wrote that kinetic energy equal potential energy. No, not necessarily kinetic energy equal potential energy. You are going to say to wait and see this. Okay, so but gravitational potential energy or potential energy is the energy of position, of height from a certain standard, from a certain relative position. Okay, so GPE in joules equal the mass, it's supposed to be in kilograms, multiplied by g, it's 10 meters per second square, multiplied by the height in what? In meters. Good? Okay, let's do these small questions. Okay, tamam. And these small questions, okay, what they ask here. First question, question number 6, what they say. A 1,200 kilogram, this is the mass. A 1,200 kilogram car is moving at 12 meters per second. This is the speed, V, okay? On the third floor, 30 meters above the ground. This is what? This is the height. So we have the mass, the speed, and the height. Find A, its kinetic energy, its potential energy. Now, the formula, it's obvious that kinetic energy initially in this position equal what? Half mv squared. So, which is half multiplied by the mass, which is 1,200, multiplied by the speed, which is 12 square. And by using the formula, we will get how much? Half times 1,200 multiplied by 12 square. And the answer will be how much? 86,400 watt joules. شكرا يا حبيبة. شكرا يا أدهم. Yes, شكرا يا شباب. Okay. But here, they ask about its potential energy. So potential energy at this position, initial position now, it's equal to what? mgh, mass times gravity times what? Times height. So the mass, which is 1,200, multiplied by g, the gravity acceleration on Earth, it's 10, multiplied by the height, which is 30 meters above the ground, and the answer will be how much? Exactly 360,000 watt joule. شكرا. يا سلام يسلموا ايديكم. Okay, so what we just find out? We find out the kinetic energy initial I and the potential energy initial I in this position, in this situation. Okay? From where we get 10, 10 is the gravity acceleration. It's constant value. You have to put it in as 10 for the syllabus that they are going to do the May-June session. But for next year, okay, for 9th grade or 10th year that they are going to do the exam next year, they change it from being 10 meters per second square to become how much? 9.8. I told you about that now here. The G, the gravity acceleration is on Earth is 10 meters per what? Per second square. Okay? Tamam. Why the speed? Why the speed is square? This is the formula. More details, we are going to talk about that later. Okay, why it's square. So half times mass times speed square. This is the kinetic energy, and and mgh. This is the potential energy. So these are the total energy that the car has it while it's moving at this speed, at this position, at this height. Okay. Part B. If the driver, Marwan, we are going to answer this question later. What do you think the best energy resource? We have many energy resources. It depends on the situation. Okay. If you are living close to a volcano, geothermal. If you are living in a desert, solar. Okay. If you live in a good area that has wind, wind. If you are close to the beach, water waves. It's etc. etc. It depends on the situation. Okay. Tamam. See, if the driver accidentally lose control on the car to fall from that floor, the third floor, 30 meters above the ground, at that speed, the same speed, 12 meters per second, to reach the ground and hits it. To reach the ground and hits it. Find the maximum speed of impact. Now look here. We said in the beginning that energy is conserved. And you told me that conserved, that means the total energy before equal the total energy after. You say it in a different way. You say that energy cannot be created or destroyed. It's only transferred from form to another. So that means the total energy, the total money that I have it, okay, I had it before, 50,000, it becomes 20,000 plus the car, okay? So when I have several forms of energy, I add all these forms of energy together, okay? So when they ask here, find out the maximum speed of energy of impact, and they repeat this question in different ways in the last years, especially in this new syllabus after 2016, we have to know that total energy initial is equal to total energy final. What that means? That means the kinetic energy initial plus the potential energy initial plus the work done. If there is, if he push gas, if something push the car and hit it from the back, okay, plus the work done, something to increase the energy that the car has it, okay, that's the total energy before, equal the total energy final, the total energy after or at the end, okay. So the total energy at the end is what? Okay, kinetic energy final plus potential energy final plus the work done against friction, like air resistance or energy dissipated or wasted in any way, okay? So this formula, it's very unique formula that every year in the last couple of years, they ask about it and you can use it everywhere when they ask about energy before and energy after certain position or certain situation, okay? So that means the total energy before and the total energy after, they are equal. What was the total energy before? It was the kinetic energy here, plus the potential energy here, plus there is no work done. They didn't mention, so I assume that there is no work done by gasoline. He didn't step more on the gas, okay? Or there is nothing hit the car from behind to give it work, okay, to increase the speed of it, okay? So that means 80, I'm sorry, let me change the color. 86,400, okay, the kinetic energy initial plus the potential energy initial 3,600, okay, thousand, okay, plus what? Work done, nothing, they didn't mention it. So I assume that there is no work done on it, is equal the kinetic energy final when it reached the ground. When it reached the ground, how much is the maximum speed? I don't know. So it's half m, the mass of the car doesn't change, multiplied by v squared. They ask about v. Here they ask about this v, the maximum speed of the car. They ask about this v. And they use the word maximum. That means they assume that there is no energy dissipated or lost by friction or air resistance during falling. So plus, how much is the potential energy final here when it reached the ground? There is no height. I assume it's what? It's zero. So there's no potential energy because it already reached the ground and hit it. So there's no potential energy. After that, it bounces, it explodes. Whatever it happens for the car, it doesn't matter for us. Plus, there's no energy energy wasted by friction or air resistance since they didn't mention it. So that's why they use the word maximum. So we assume that all the energy before is transferred into what? Into kinetic energy, okay? So by using these formulas and substituting that the mass, which is 1,200 kilogram, we will find out that the speed equal the square root of what? Of 86,400 plus 360,000 divided by half multiplied by what? The mass of the car, which is 1,200. That's math. Okay, what I did here, I did math. Okay, I divide all this divide by half m. Then I put a square root, and my answer will be how much? Who has a calculator? The answer will be square root of 744. The answer will be 27.3. 27.3 meters per second. This is the maximum speed of impact of this car as it falls from the 30 meter above the ground with a speed of 12 as it falls down. So as it falls down, yes, thank you, Leila, the speed keep increasing because of the acceleration, okay? And there is no air resistance, so we assume that all the energy is transferred from potential and kinetic into what? Into kinetic, okay? Tamam? So again, what do we have here? The total energy before equal the total energy after. So what that means? Kinetic energy initial plus potential energy initial plus the work done on the system, on the car, on the body, on the object, whatever we are talking about, equal kinetic energy after or final or in the second situation plus potential energy in the second situation, how much is the height, plus work against friction or air resistance or drag force. It doesn't matter. Okay, we're going to talk about that in details. So by doing that, V equal the square root of all this divided by half times the mass, which is half divided multiplied by what? 1,200, the mass of the car, and the answer will be how much? 27.3 meters per second. Okay, let's see another question that talks about the same idea. Okay. I don't think I forget that, Ahmed. Shukran ilak. Okay, let's talk about another question. Okay, about a different idea. Okay, about also falling object. They usually bring object out that falling on the object that rises. Okay, so we are going to answer a lot of ideas like this. What they ask here: a 2 kilogram mass, a 2 kilogram stone, is it dropped? Drop, that means initial speed equal how much? 0. That means there's no potential energy. Sorry, there's no kinetic energy. It's dropped because the speed initially is 0. U equals 0. That means there is no what? Kinetic energy. The kinetic energy is 0. Okay. From 20 meter height, this was the height initially. Okay. Tamam. Above the ground and hits it. Okay. This object, this stone, falls. It has a height here of 2 meter. Okay, this height is 20 meter to reach the ground. As it falls, as you can see here, it has only potential energy. There is no what? There is no kinetic energy. But during falling, as it fall down, and accelerate, that means there still has potential energy plus what? Kinetic energy. As it reaches here and hits the ground, okay, there is no height. As it reaches here and reach the ground, there is no height, so only has what? Potential energy. There is no what? It only has kinetic energy. There is no potential energy. Let's repeat that. So as it was at the top, okay, and it was falling, it was dropped. That means the initial speed is how much? 0. That means there is no what? Kinetic energy, only what? Potential energy. Okay? Is it dropped? Dropped, that not thrown, dropped. Dropped means that there is no speed initially. Okay? During falling, because the height decreases, that means this potential energy is converted from being potential energy to be potential energy plus kinetic. As it reaches the ground, and the moment it hits the ground, it has 0 height. So there is no potential energy, only what? Kinetic energy. What they ask? Find out the maximum speed of impact with what? With the ground. So what I would say? I'll say that potential energy initial plus kinetic energy initial. It's not necessary to write the whole formula in the exam. You have to understand it, okay? Plus work done. There is no pushing force. It's dropped, okay? So it's 0 equal potential energy final as it reached the ground plus kinetic energy final as it reached the ground, okay? Plus work against what? Against friction like air resistance or any other what? Forces, okay? تمام? Okay? طيب. So what we're going to do? The potential energy initial, okay, which is mgh initial, plus kinetic energy initial, which is 0, plus work done, which is 0, equal potential energy final, which is also 0 as it reached the ground, plus kinetic energy final, which is half mv square, half mv square, okay, plus work against friction. I assume there is no work against friction. That's why they use the letter maximum, okay? They didn't mention it. So you can use now the formula that potential energy initial equal kinetic energy final. That's what most of the teacher teach the student, and that's not exactly 100% correct. In this situation, it's correct, okay? So let's continue putting values, okay? What do we have here? The mass can be cancelled with the mass. So GH, okay, is equal half what? V square. That means V equal square root of 2GH. Now, this is a special formula, a unique formula that I'm going to use it only in this situation when there was an object that was dropped until it reached the ground. Not necessarily all. So don't memorize this formula. في ناس بلاش يكتبوا لي إياها. Don't memorize this formula. Okay, that's why I wrote it. I don't wrote it usually. Okay, so which is equal to square root of 2 times 10 times what? 20. By using the calculator, the answer is 20 meters per what? Second. So in this situation, if we drop an object from a height of 20 meters per second, it will hit the ground without air resistance with the speed of how much? 20 meters per second. If it was higher, 30 or 40 meters, the speed will be more than this, okay? It's not by accidentally the answer 2020, accidentally they have the same value, but not necessarily always the same value, okay? Tamam? So, but in reality, your answer in part A is wrong. In reality, your answer is wrong. Explain why and state which speed is faster, your calculation or the real value. What do you think? Which one is faster? My calculation? In reality, it will be 20 or more than 20 or less than 20. My calculation, it will be faster. Thank you, Muhammad. Habib, my calculation is higher. Okay, thank you. That's why I use the word maximum. Shukran. Habiba. Tamam. Who else? Why? My calculation is faster. Shukran, Marwan. Who else? Who else? Explain. Please explain. Okay, I will explain it. Okay. Tamam. What do you mean with first second? As it reached the ground, not first second. As it reached the ground, okay. In the moment that it reached the ground, okay, there is no height. Tamam? Again, question 7, part A. The total energy before potential energy plus kinetic energy plus work done equal potential energy final plus kinetic energy final plus work done. Initially, it has only potential energy because it was dropped. There is no speed. Okay, so potential energy initial equal mgh. There's no work done. Potential energy final, as it reached the ground, there is no height, only kinetic energy, half mv squared, and we assume there is no air resistance during the way it falls down. So that's how we get the answer. Aha, bravo, ya Elaf. Shukran, ya Elaf. Yes, the answer, my calculation is what? Is faster. شكرا للشباب والبنات اللي بعثوا لي الجواب. Why? Because in reality, there is what? There is air resistance. شو بيعمل هذا الاير resistance? Dissipated some energy. يعني خلي make some of the energy wasted. Dissipated some energy. Dissipated some energy. That means the kinetic energy finally it will be less than my answer. Okay, the final answer, okay, the final kinetic energy, because there will be a value here for the work against friction. It will not be 0. It will be, for example, 20, 30, 50, it doesn't matter. Okay, so I will subtract it from the original value, so it will not be 20 meters per second. It will be what? Less. Okay, tamam? Okay, now next, part C. As it falls 8 meters. Now again, the whole height is how much? 20 meters. It was here. As it falls 8 meters, okay, and reach this point here, this position. How much is the height? 20 minus 80, bravo. So it will be how much? 12 meters, okay, from where? From the ground. As it reaches here, initially, it has what? Initially, in this position, it only has what? Potential energy, as we explained here. Okay, it only, but at this position here, it has both potential energy because it has height, gravitational potential energy, plus it has what? Kinetic what? Energy at this position. So what they ask, as it falls 8 meters from its position, from its initial position, find out its speed, the speed here. So what we are going to say, we are going to say that we are going to use the whole formula, okay, but in a short way. Potential energy initial here, plus kinetic energy, which is 0 initial, plus work done is 0 also. There is no potential energy, there is no work done. I didn't push it, I drop it, okay, is equal to potential energy final plus what? Kinetic energy what? Final, okay? Potential energy at this position plus kinetic energy at this position. So let's substitute the values, okay? mgh initial equal mgh final, okay, plus half mv square. They ask about this speed. They ask about this speed, the v square, okay? They ask about this one, okay? Tamam. So what we're going to do? We're going to continue. Can we cancel m with m with m? Yes, of course we can cancel m with m with m. So exactly, tamam. What we're going to do? M with m cancel out. So g, which is 10, okay? G, which is 10, multiplied by the initial height, which is the whole height, 20 meters. Okay, I'm trying to explain, Kinsey. Attention, لو سمحتي. Attention, if you please. Okay, so m with m cancel out each other from the main formula here. So mgh 10 times 20. Okay, the gravitational potential plus the height, initial position, 20 meter, equal gravitational potential energy, which is gravity acceleration. Okay, Our gravitational potential energy final, mgh, they cancel out, m with m with m, times the final height, which is 12, the height from the original position, from the where the ground is, not from where it falls. So it's 12 plus half multiplied by what? V square. 10 times 12, it's 120. Move it to the other side, it will be negative 120. So how can I find the value of V? V, it will be square root of 10 times 20, which is 200, minus 10 times 12, which is 120. I'm doing math now. Divide by how much? Divide by half. Under what? Under square root. So our answer will be square root of 160, and the answer will be 12.6 meters per second. So at this position, initially, it was speed of 0. As it falls down, the speed increases. As it falls the first 8 meters, it has a speed of 12.6 meters per second approximately, and the speed keep increasing until it hit the ground with a speed of how much? With a speed of what? Of a 20. Good. Now, do they bring questions like this? Actually, mixed questions, not exactly like this. We are going to answer now past paper questions, and you are going to see how we are going to use this formula in different ways. Okay. That about energy and energy forms. This is the first part of our lesson. Second part, we are going to talk about work, then power, then efficiency. So now, what's the meaning of work? What's the meaning of work? The work is not included in the syllabus, in the definition of it. But as we know that any work, okay, it's use energy, and this change of energy is equal to the work, and we are going to use it to move an object. When an object is moved, we need a force, right? So this force, and whenever it's bigger, the work is bigger. And whenever I move the object farther, that means I need a bigger work. So what is the work? Is the product. It's not a definition, okay? It's not included, but we have to understand it. Is the product of a force. The product means the multiplication of, okay, is the product of a force moving an object a distance in its direction. A distance in its direction. Okay? It's very important to make the force and the direction parallel to each other. So if this is a force in this direction, the distance or the displacement that the object moves is supposed to be parallel in this direction also, okay? In the same direction, to the right, up, whatever, okay, to make it work. So from this, okay, what is the formula? What is the formula for the work? Work equal force multiplied by what? Distance, okay? Tamam? Okay, thank you. Now, again, who can tell me what's the unit of work? Yes, what is the unit of work? Work supposed to be in what? In joules. Yes, thank you. And the force must be in what, يا شباب? The force must be محمد ذكرني بقصة جميلة. شكرا. Okay, the force supposed to be in a Newton, capital N, not small n, and the distance supposed to be in what? In meters, not in what? In centimeters. شكرا يا يوسف يا نور يا عبد الرحمن يا محمد. شكرا لكم. Okay. So let's answer these simple questions. What they ask. An object is pushed by 300 Newton. An object is pushed by 300 Newton, a distance of how much? 20 centimeters. That means you have to convert it into meter, 0.20. How we convert from centimeter to meter? We divide by how much? Exactly, we divide by 100. Shukran. Calculate the work done on the object. So work equal force multiplied by distance. So 300 multiplied by 0.20 or 0.2, and the answer will be how much? 60 what? 60 joules. That's the work. Okay? Now, this work can be potential energy, can be kinetic energy, we don't know, okay? How this work, it changes the form of energy, we don't know. It depends on the question, okay? Another question, to be more specific, okay? Okay, what they ask here, Ahmad, okay, Salma? Is it okay, Salma? Tamam, okay. Now, so an object is pushed by 300, okay, Newton, a distance of 20 centimeter, we have to convert it into meters, 0.20 by divide by 100. Calculate the work done on the object. So work equal force multiplied by distance, the force which is 300 multiplied by the distance that's supposed to be in meters, and the answer is what? 60 joules. Next. Ahmed is 80 kilogram. They give us what? The mass. And he goes up stairs of how much? 20 meters. This is the height that Ahmed went, okay? Tamam, Ahmed, he's fat, yeah. At 80 kilogram, yeah, it depends on his height, doesn't matter, Muhammad. Shukran. Above the ground. So this is the height and this is the mass. Calculate the minimum work done to go up. The work done, it's the energy transfer by his going up. Okay, so we know that it's supposed to be chemical energy and becomes, as he go up, potential energy. So we are not talking about the chemical energy and the heat. We're going to talk about only the gravitational potential energy as he go up. How? Look here. How is this? So we know that work equal force multiplied by distance. Now, since he is going upwards, so the minimum force is the weight. To lift any object upwards, you need at least a force equal to his weight, or okay, to Ahmed's weight, to go upwards. Multiply by the distance that's go up of the ground, which is h. And as we learned before, that the weight, it's equal mg. Multiply by h. So look what I'm talking about here. I'm talking about gravitational potential energy. So this work is minimum since I'm talking about what? I'm talking about only about the energy transferred, not chemical, not kinetic, not heat, only gravitational potential energy as he go upwards, okay? So which is equal to the mass, which is 80, multiplied by 10, which is gravity acceleration, multiplied by the height, which is 20, and the answer will be what? 16,000 what? Joules. Tamam? So the weight, which is 80 times 10, mass times gravity, multiplied by the height, or the change in the height from the ground position, there is no height 0, to the height of 20. So 20 minus 0, it's 20. Okay? So that's the answer. Now, state all the energy transformation during that. Okay? How much calories that he burned, it depends on how much athletic he is, okay, and how much the efficient he is. Okay? State all energy transferred during that. As we said before, it was chemical energy. And this chemical energy is transferred to GPE, gravitational potential energy, plus kinetic energy in his arms, plus heat energy inside his body to warm up. Okay? All these are the energy that transfer during his body. Maybe a little bit sound. It doesn't, not necessarily the steps produces sound. Maybe he's wearing a good shoes that doesn't produce a sound. Okay, Tamam, Muhammad. Okay. Now, a very important definition that maybe they ask about it from while to while is the definition of power. When I put tech here, you know that it's in our syllabus to define power. What's the definition of power? Question 9, can we use rho GH? No, rho means density, and density times gravity times height is the pressure. That's another formula. They didn't ask about the pressure. Shukran, Muhammad. Okay, what's the power? 5 words. The rate of doing work, or the rate of transferring energy. This is the power. Weight, the force to lift any object upwards, Ya Abdurrahman, Muhammad, is the weight, and the distance to lift upwards is the height. Okay, so write down. Okay, write down. Yes, thank you, Selma. Is it okay? Okay, and the unit is joule per second, which we call watts. Yes, shukran. So the rate of doing work, the rate of doing work, that means the rate every second of doing work, or you can say the rate of transferring energy, the rate of transferring energy. So that's why power, the formula for it, okay, power equal work over time or energy over time. And as you told me now, as some of you sent me, what's the unit of work? What's the unit of work? The unit of work is supposed to be in what? In joules, yes, thank you. And the unit of time is supposed to be in seconds. So the unit of power is joules per second. You have to convert it into seconds so you can write down watt here. The unit of power is watt. Okay, tamam. Take screenshot, no problem. Tamam. Okay. Another question here, a simple one. Question number 10. What do they ask? An object is pushed. You are welcome. An object is pushed by 3,000 joules in a minute. Now we have to convert it from minute into second. How many seconds in every minute? 60 seconds. Yes, exactly. So an object is pushed by 3,000 joules, okay, in a minute, 60 seconds. Calculate the power of pushing this object. Now we know that power equal work over time, which is equal 3,000 divided by 60, and the answer will be how much? It will be 50 watt. Okay, good. شكرا يا نور, برافو عليك, صح. Write this down. Another question about a friend of Ahmad. His name is Ali. Ali is 80 kilogram, and he goes upstairs at 12-meter height. So this is the mass, this is the height, and that happens in how long time? 20 seconds. He's slow, he's not fast. He didn't do that fast. He want to do that slowly. 12 meter in stairs, that means approximately 3 floors in 20 seconds. That's an average, not too fast, not too slow. Okay, so calculate the minimum power he did during that. We said before here that when you go upwards, the work that you are going to do you are doing as potential energy, gravitational potential energy. So the same thing here. So they ask about the work, the minimum power, and we know that power equal work over time. And the work here is the gravitational potential energy because they go upstairs. So GPE over what? Over the time. And we know that GPE is equal to mgh divided by time. So how much is the mass? Is 80 multiplied by g, which is 10, multiplied by the height, which is 12. And that's happened in how long? 20 seconds. So the power that he developed as he go upwards as gravitational potential energy, the minimum power, it's 480 watt. 480 watt. Okay, good. Okay, explain why the power that he produced is more, in reality, is more than your answer. Who can tell me why the power that he produced, okay, is much more than our calculation? Because we didn't calculate the kinetic energy in his arms and the heat. Exactly. Shukran ya Marwan. Bravo. So a lot of energy is what? That he used it or he burned it. Okay. Tamam. This is the minimum, not maximum, not average. This is the minimum work or the minimum power. Bravo. Bravo. So Can we write a joule per second? Yes, you can write joule per second, but it's better to write watt, okay? Tamam. So write down because not all of his energy is used as GPE, gravitational potential energy. Some is dissipated. Some is dissipated into heat, into wasted energy, into wasted energy as heat. Good. ماشي الحال. برافو يا عبد الرحمن، شكرا لكم. Now also the definition of efficiency is included in the syllabus. شكرا يا مروان. The definition of efficiency, it's included in our syllabus. What's the meaning of efficiency? Now again يا شباب, if I want to buy a car, okay, I have 50,000 GD, I will buy the car by 30,000 GD, 20,000 GD remains, okay. Now not all the car, the 30,000 is used for this person, okay, the old owner for the car, okay, it's 100%, he used all this money as a profit for him because he was buying the car by less money or more money, and he sell it for you. So not efficient, not 100% efficient. But if I want to take this car, okay, the same thing here, and see how much fuel I use. Whenever the car is using fuel, okay, and you put your hand on the engine, you'll feel that the engine is what? Hot or cold? Exactly. You feel that the engine is hot. Why? Because not all the chemical energy in the gas is used as kinetic energy. It's some of it is used as what? Thermal energy to heat up the engine of the car. The same thing when you charge your phone. When you charge your phone, okay, you find after you charge your phone, you find the phone and the charger are hot. That means not all the electrical energy is transferred 100% efficient to what? To your phone. So what's the meaning of the efficiency? It's the ratio. It's the ratio of useful output power or energy, okay, to the total input power. This is the definition. So it's the ratio, as we said here, it's the ratio between useful output power into what? Total input power. So that's why the formula for the efficiency equal power out or energy out divided by power in or energy in, multiplied by how much? Multiplied by 100%. What's the unit of efficiency? The unit of efficiency is percent usually, okay? It doesn't have a unit because it's a ratio. Watt over watt or joule over joule, they cancel out each other. You can say ratio. Sometimes they give you the efficiency as 0.3. Maybe they give you 30%. So if they said the efficiency is 0.3 or 30% is the same thing, okay? Tamam? Not necessarily all the engines they need to be heated up. It depends on the energy. For example, electrical energy, like electrical cars, they don't need to heat it up, but it's still heat up because of the resistance of the electric resistance in the wires inside the coils inside the engine. Okay. Shukran for your question, Muhammad. Yes. Okay. Now let's do this example. What they ask. A machine, our time is up, only 3 minutes left. Let's do this question. What they say. A machine produces a power at a rate of 200 watt. That's the output it produces, okay? By using electric power, that's the input. So this is the out. By using an input power of how much electrical power of how much of 800, calculate the efficiency. Yes, thank you, Adham. It's 25%. So it's power out divided by power n times 100%. And by using calculator, you don't put percent in the calculator. It will be 200 divided by 800 multiplied by 100%. And the answer is 25%. Or you can write it 0.25. Okay, both are accepted. Okay, tamam, not 0.25%. No, you can't write 0.5%, 25% or 0.25. Don't mix it up. Okay, Adham. Shukran, shukran. Last question is a very hard, unique question. Okay, they bring like this question maybe only twice in the last 20 years. Look what they said. A hydroelectric power plant. Hydroelectric, as we remember, it uses gravitational potential energy, okay, to move the water, to rotate turbines, to generate electricity. Okay, hydroelectric power station, okay, generate electrical energy at a rate of 12 megawatt. What that means, 12 megawatt? It means 12 times 10 to the power of how many zeros? Yes, 6 zeros, million. Thank you, Muhammad. Okay, watt. And it is how much efficient? 40% efficient. That's good. Not all the hydroelectric power station 40% efficient. They are less than 30. But let's assume that this one is 40% efficient. What they ask, part A, calculate the amount of input power. Now, let's remember, the output is electrical. What is the input? The output is electrical in hydroelectric. What's the input? Power. Is the power of what form of energy? What was the form of energy here in this question? Yes, yeah, Muhammad. Bravo. I will not say the answer. Tell me the answer. Yeah. Who can give me the answer? Megawatt means million watt. Okay. Not chemical energy. I'm talking about hydroelectric, water falling. So what was the energy for the water before? Exactly. Shukran ya Salsabil. Shukran ya Muhammad. Shukran ya Noor. Gravitational potential energy. So efficiency, there's a pushing force. It's not energy. So efficiency equal power out divided by power n, that's what they ask, multiply by 100%. Now, I can switch between these two in the math, okay? So power n, okay, equal power out, or any other trick in math you can do, multiply by efficiency, divide by efficiency, multiply by 100, okay, which is equal 12 divided by 40%, multiply by 100%, I forget to write 8%, and the answer, it will be 30 megawatt, or 30 times 10 to the power of 6 million watt. Okay? Tamam? Hello? The hardest question ever, part B. Look what they ask. If the dam has a 20-meter height, this is the height, this is H. Find out the rate at which the water flows out from the dam in kilogram every second. So what they ask for? They ask about mass every second. Divide by time. That's what they ask for. طيب. Why they give us the height? This height is the gravitational potential energy. Bravo, Muhammad. Thank you. So the 30 megawatt is what? Is the gravitational potential energy. So gravitational, I'm talking about power here, okay? So the power n, okay, the power n is equal to gravitational potential energy divided by t, time, okay? So the power n, which is 30 million watt, okay, is equal to what? To mgh divided by what? Divided by time. They said every second. Okay, let's substitute the values. How much the potential, how much the power n? It's 30 times 10 to the power of 6. equal the mass that they ask about it, okay, multiply by 10, okay, multiply by the height, which is 20, and this is m over t, the time is 1 second. So m divided by t equals 30 million divided by 200. So mass divided by time, that what they ask about it, it's 30 million, I'm sorry, 30 million, 30 times 10 to the power of 6, divide by 10 times 20, which is 200, and the answer will be 150,000 what? Kilogram per second. That's how much water comes out from this dam, from this hydroelectric power station to produce what? Electricity. Now, what's your homework in our group? Your homework are the multiple choice questions in page 6, 7, 8, 9. Okay, these are your homework. Okay, until page what? Until page 11. This is your homework. The 21 multiple choice questions, they will need approximately less than 25 minutes from you. Okay, if you have any question, you can stay online. If you don't have a question, you can leave. Have a nice day. Assalamu alaikum wa rahmatullahi wa barakatuh. I'm happy for having all of you. احنا كان عندنا تقريبا 70 طالب بيحضر الحصة. الماكسيمم بيك له بعدين بلش يقل عدد الطلاب. I'm not going to leave until all of you leave and ask me all their questions. Yes. Can you please go شو يعني go You are welcome, Noor. You are all of you are welcome. Okay, كلا كثير ناس up where? Okay. يا الله ها. تمام. Where can we get the paper from? I will send it on the links. Okay, and from where you get the link, you can ask. Okay, I downloaded in several groups. You can go to my channel, Telegram channel. Okay, Dr. Ahmad Al Faris. You can ask the person that sent you the link to get it. Okay, tamam. Who has a question? Any question, you can send it to me. Okay. Yes, Muhammad. Fadl. The definition of energy is not included in the syllabus. There's no real definition, okay? We can write a definition for us to understand what the meaning of energy, but there's no definition for energy included in the syllabus. Okay, for the homework, can we send the WhatsApp? Okay, check no problem, ya Muhammad, no problem. Farah Hisham, in the first page, thank you, okay, tamam. Muhammad, or you can give us mark scheme. I will give you mark scheme. Do you want this mark scheme? No problem. I can send this sheet. This worksheet. I can save it now and send it to you again. No problem. You are welcome, Muhammad. Okay. Any other questions? بلشوا الصبايا والشباب ابعتوا لي على الواتساب. Okay. Any other questions? Any other questions? Should I send the homework, Maryam? Maryam, you are not with me in the group, but you are welcome. No problem. Send me on my number if you want my number. My number is, let me write it down for you, is 962, the code of Jordan, 79982. Okay, then 8524. This is my phone number. You can send me whatever you want on the WhatsApp. Do you remember my question on the WhatsApp group? Marwan, you can't believe. I will show you how many messages I got now in the WhatsApp. Look, and I just open it now. Look, I have a lot of questions. So Marwan, you can remind me, okay, whenever you want. Okay, inshallah, I can answer all your questions. Okay, you are welcome. Good night. Thank you. Shukran. How many do we have now? 9 students. Okay, homework from which page to which page? All the multiple choice questions from page 6 to page 11. All the multiple choice questions from page 6 to page 11. You are welcome. No problem. يلا يعطيكم العافية. You are welcome. أهلا مع ألف سلامة. يلا السلام عليكم ورحمة الله وبركاته.